Hello and welcome to today's Simpleware webinar. Thank you very much for taking the time to join us today. I'm very pleased to say we have a customer webinar where one of our customers will be providing a bit of detail and a presentation on what they do and how they use Simpleware software. The customer is 3D LifePrints, and they're going to be presenting on how they produce 3D anatomical models for surgical planning and training with Simpleware software. We'll begin the presentations in a few moments, but just before we do that, allow me to introduce myself. My name's Tim Williams. I'll be organising the presentation today and running the Q&A later. I am an applications engineer as part of the Simpleware product group at Synopsys. My colleague David Harmon will be introducing Simpleware software. He is a business development manager in our group. And then the customer is Michael Richard, and he is the head of engineering at 3D LifePrints. So just before we start, the agenda and instructions. Today we will have a presentation followed by a Q&A. You'll notice that you've been muted, and attendees will remain muted throughout just to make sure there are no audio conflicts and feedback and noise problems, and make sure everyone can hear things clearly. If you do have a question, you can type those in to the questions area in the GoToWebinar tool pane, and we will get through as many of those as we can at the end of the presentation. If we can't get to your question, we will follow up by email after the webinar and answer those then. One additional note, the webinar is being recorded and it will be made available for download afterwards. So if you do have any issues or internet dropouts or things like that, please rest assured that the webinar will be available afterwards for you to download and view at your convenience. If you do have any other problems, again, please report these in the Q&A toolbox. So without further ado, let me hand over to my colleague David Harmon to begin the presentation.
Thank you very much, and welcome everybody to our webinar today with our customer 3D LifePrints. Today is really focusing on 3D LifePrints and how they use our software, the Simpleware software, within their workflows for producing 3D anatomical models for a variety of different applications, and these include surgical planning as an aid for that process, and also training for medical professionals if they're planning a procedure, or even in an educational setting where they're learning how to do a procedure for the first time, and there are limitations on training with real examples of anatomy, for instance. Today, I'm going to give you a short introduction to the Simpleware product group at Synopsys and what we do with our software and what it can offer you. And then I'm really going to hand over to 3D LifePrints. So Michael Richard, head of engineering at 3D LifePrints, is here with us today. He's going to take you through who 3D LifePrints are and how they utilize the Simpleware software within their processes. Okay. So, as I said, an introduction to the Simpleware products group. We are really focused on developing high-end 3D image processing software, and this really accounts for 3D images from a variety of different sources, including CT and MRI in the life sciences arena. Our focus is entirely upon ensuring we can analyze the images from those different modalities as quickly as possible and produce what is needed to get to the next step of analysis or design as quickly and efficiently as possible, so time isn't spent on the image processing side or segmentation side when it's not necessarily needed. So in lieu of this, to aid this really technology, we have a dedicated sales and support team here in the headquarters, and also we have sales distributed throughout the world as well, with a global presence. Our focus really has always been in the clinical and broader life sciences area, but we also have a focus on materials applications and industrial applications too, so we have capabilities in those different fields as well. So if we're thinking purely about the clinical industry and how hospitals and different areas of radiology, for instance, are using our software, and what our software offers those industries, really with things like preoperative scans in hospitals, whether they be from CT or MRI, or even post-operative scans, and that probably most likely, of course, be CT in the area of orthopedics. we're able to look at those scans and take vital measurements. So we're able to use our tools to segment the structures, the anatomy within those scans as quickly as possible. We've just recently introduced a very exciting tool for the automated segmentation of orthopedic structures, so the hip and the knee. So we're able to automatically segment these anatomies and then use automatic landmarking that's completed within that process to take measurements from certain areas. But we're also able to do a lot of more manual type measurements that can aid in the planning process. So really our focus here is to aid the planning of surgeries and assessment of really treatments that need to be completed to enable patients to recover well from a surgery. So along with this process, kind of in parallel, so with the planning process, we're able to allow 3D printing from the structures we segment. So what that means is our process can be utilized to create structures that can then be used in the design of patient-specific instruments, for instance, so cutting guides and the like, but also 3D anatomical models, which is more the focus of this webinar today, for surgical planning and for the education of patients for the operations they will be undergoing, and also the training of medical students within the educational arena. So really, there are a variety of different applications here. There's the cutting down of intraoperative time and improving clinical outcomes, but there's also the training side and also the education of patients into the sort of the procedures that they will be undergoing. If we're looking at how our software can be used within the medical device industry, really, if you're looking at orthopedic instruments or even devices and implants, then our software can be used to analyze how different designs are reacting with the human body or the expected anatomy within the patient. So with our software, we can go through the segmentation steps and produce the models of the patient, or this could perhaps be an average percentile and even a patient-specific case. So we can produce the patient-specific anatomy. Then CAD models, different CAD models of different designs of implant can be imported into those structures. Everything can be meshed together and models can be produced for the simulation of those structures so that we can assess the performance of these implants, their positioning, their sizing, for instance, on the overall performance of the implant itself. So we can assess how that procedure, how well that procedure will have gone if the various different placements are used and the various different sizes are used, so that really the implant size perhaps or the positioning can be optimized for the best outcome. And this also helps feed back into the design process to see how perhaps the design should be changed for the best outcomes too. In the area of product development, of course, a similar approach can be taken to integrate human body models with the designs that are being produced for different products. In this case, I'm showing a helmet, so we can integrate a helmet with a model of the human head to assess how this helmet will protect the user from head impact, for instance. So we can assess, in this case, a very complex model of the head. We can assess how the stress is propagating through the head, and if that's reduced by certain designs of helmet. But also we can look at the planning side, so we can check the fit of the helmet, for instance, and incorporate different parts for that helmet, for instance, the padding, and see how that affects things later on with 3D printing. Simulation and 3D printing. 3D printing could be used in the area of customizing the products and making sure that they are suitable for really specific cases or more generalized cases. So in summary, the various different applications you can see here. On the left-hand side, you can see really the product-orientated, so the product development-oriented applications of the software. And on the right-hand side, the more clinical-focused applications of the software, which is really where we're going to focus today. So in the area of pre-surgical planning, producing 3D anatomical models for that process, but also you can see that we have applications in the area of creating models for the assessment of physiological flows and also exporting models with lattice structures, for instance, for 3D printing. But as I mentioned today, we're really focusing on the applications of 3D life prints, which is printing anatomical 3D models for surgical planning, aiding surgical planning, and the education of patients, and producing models for medical training. So just to briefly overview the different tools within our software, the Simpleware software, is a GUI-based software. So you can see an example of the GUI on the right-hand side with a head model, a complex head model there. We can go through a variety of different processes, visualizing the data that we import. So whether that's purely the image data or the segmented data, we can visualize that data and we can create animations with it. We can go through the filtering and segmentation process. As I mentioned earlier, we're introducing very automated segmentation capabilities that are based on artificial intelligence, so we can really speed up the process and get very good results. We're then able to go through the process of measurement and quantification. We can integrate CAD with image so that we can assess different designs with human anatomy. And then we can go through the process of 3D printing. We can export models for 3D printing, and we can export models for CAD design and also for simulation, so FEA and CFD, for example. So briefly, just a really quick run through of the different steps. We would start by importing the data that we've obtained from a scanning technique, so whether it's CT or MRI. We can then go through the segmentation process. Here we have a variety of manual processes, all the way through to very, very automated machine learning based segmentation routines, through to measurement and analysis. So we can look at wall thickness, automatic wall thickness analysis, and also things like centerline analysis, through to CAD and image integration for assessing the positioning and sizing of different implants and how they affect the end result for the patient, through to model generation, whether that be for 3D printing or for simulation with a mesh for FEA, for instance, or CFD. So with that overview of the Simpleware software, I hope that gives you a good introduction to what we can do. At this point, obviously, I want to hand over to 3D LifePrints to give you an overview of their products and their capabilities and how they've used the Simpleware software within their workflow. So they're really going to show you exactly what they can do and how they've really, really positively affected clinical outcomes with their models and helped people live better lives through planning with the anatomical models that they've been able to provide. So here I'll introduce Michael Richard, the Head of Engineering at 3D LifePrints, and he will take you through the slides that 3D LifePrints have put together. Thank you very much.
Thanks a lot, David. Hello, everyone. Welcome to this webinar. My name is Michael Richard, and I'm the Head of Engineering for a company called 3D LifePrints. I'm also one of the co-founders for this business of ours, which began about 5 years ago here in the UK. And the majority of our work here is done in and around NHS hospitals, where our goal as a business is to set up 3D printing hubs. 3D printing hubs is normally several 3D printers, several workstations, some software suites such as Simpleware, and a trained biomedical engineer who has knowledge of both anatomy and engineering and is able to provide services and skills to produce a variety of medical devices and anatomical models. I'm currently based in Oxford, where I am heading up our 3D printing hub here in the Nuffield Orthopedic Centre. And I've been working together with David and his team for some time now on many, many cases, probably done a couple hundred so far within Simpleware across our various sites. So I want to give you all a quick overview on 3D LifePrints. 3D LifePrints is one of the UK's leading medical 3D technology providers. So as I specified earlier, we take software, hardware, and staff, wrap them up in a package and put them into a hospital setting where our engineers can take patient data such as medical imaging, CT, X-rays, echo, and MRI, and turn those into accurate patient-specific models for all sorts of purposes and reasons that we'll talk about in a minute. We currently work with over 20 hospitals around the country. We work also with many medical device manufacturers and leading universities and research facilities, in essence, to produce anything in the medical sphere that involves anatomy, 3D printing, prototyping, and design. We have the ability to produce a wide range of 3D models, both for virtual visualization, like the ones we'll be looking at today, and then also for physical realization in actual 3D printed models. Beyond 3D printed models, we also do some work with cutting and drilling surgical guides, and then finally implants, which we'll talk a little bit more about in a second. And as stated, anatomical models for all specializations, especially orthopedics, cardiology, craniomaxillofacial, and pediatrics. So here in a snapshot, you can see a little bit more about 3D LifePrint's capabilities. So we've spoken about the anatomical models, and those are the ones we'll mainly be discussing today, as those all begin their life as patient records and need to be run through Simpleware. 3D design and segmentation, you can see there an example of a surgical guide. I'll just kind of hover my mouse. So this is what I talked about the digital planning, virtual planning of surgeries and the creation of surgical templates and guides on top of patient-specific anatomies. And that can also then be used, the patient data can be used to create implants eventually. And we have wider solutions for many different medical fields, such as simulation and training, which we'll be talking about a little bit today in one of the use cases. So I like to always give a little bit of a snapshot about why we do what we do here at 3D printing. And I won't really go into depth about the clinical evidence of the benefits of medical 3D printing, but if any of you want to take a screenshot or make a quick note of some of these articles, these really give in-depth literature reviews on the benefits of using patient-specific 3D printing in the operating theater and in the medical field as a whole. So I will let all of you, as I said, take a screenshot of that if you so desire. And without further ado, I will move on to the first case in today's case studies. So this case was a particularly unique case in that it was a pediatric case of a large abdominal tumor that was brought forward to us. This was an urgent request, came in as a very timely request to our 3D printing hub in Liverpool, as this patient was going for surgery and the surgical team was not 100% confident that they would be able to remove as much of this tumor as they planned to or needed to. The surgery was initially considered impossible, largely considered impossible, with a 10% chance of survival given by some efforts. In fact, I happen to know that the parents of this patient had been around to several centres around the UK who actually refused to try and attempt this surgery just because of its complexity and its danger. So this 3D printed model was requested by the Alderhay surgical team, both to use as a communication tool to convey the severity of what they were going to undertake with the parents and patients, and also to largely aid them in their pre-surgical planning and assessments. This model detailed the tumor that we can see here in yellow, the major vessels in the area, as this was a CT angiogram was used to image this patient, and the surrounding bony anatomy. And this model was made from a CT angiogram. So I'm going to quickly take us over to Simpleware Scan IP, where you can have a look at the patient anatomy and we can understand the severity of this tumor. So I'll do a quick fly through of this case, and we can start to appreciate quite the severity and size of this tumor, bearing in mind this was a 9-year-old patient. So the tumor is outlined here in yellow, and you can start to get an appreciation for the size and area, volume, and other important anatomical areas that the tumor was in contact with. So immediately, when we switch back over to a 3D view, get a better representation. We can see the IVC, we can see the descending aorta, we can see some of the renal vasculature, and then we can see these two tubes here, which are actually stents, which were placed in from the kidneys, essentially replacing the ureter's functions and going down to the bladder. One thing which is also very noteworthy is you can see that the tumor has actually almost consumed one of the vertebrae here, causing all sorts of structural problems for the spine, endangering the spinal cord as well. And again, I'll just do a quick fly through on the axial view of this model. And we can start, we're going bottom up here. We can start to see the aorta in red. We can start to see the tumor. So the tumor, we actually use the 3D wrap function in Simpleware to gain the major mass of the tumor, as tumors aren't generally the best defined in CT. Generally, they're quite nicely defined in MRI, where they show up really brightly. However, a CT was chosen so that in addition to the tumor, we could also pull a lot of the other anatomical structures, such as the bony anatomy and such as the vasculature, vascular anatomy as well, which shows up nicely with the contrast. So that's a little 3D example of this composite model which was created. And I'll switch us back over to the case presentation. So once we were able to create this 3D reconstruction in Simpleware, we then take the model out of Simpleware and we proceed to post-process it for 3D printing. So that would involve adding a patient label, ensuring that all the files are watertight and 3D printable, and then begin the material selection. So for this exact case, it was highly important that the tumor would be in essence operable. So it was actually created in a material which is mimicking soft tissue. And you can actually see it's also semi-translucent, and you could make out the pathway of the vasculature, in this case, through the tumor. So this was able to give a sense of depth, give the ability to actually start to cut in and practice any potential resections on this tumor, while also being able to visualize the anatomy through the tumorous mass. I'm really pleased to say, and really proud always to talk about this case, because the surgery was ultimately a success, and surgeons were able to remove 90% of the tumor from the patient with no further complications. This patient has since fully recovered from cancer, and is back to living a normal life. She's gone back to school, and she's actually appeared on several news channels across the country sharing this wonderful story. So I'd love to share this case because it's just such a beautiful example about how great CT patient images were taken, were used to create a patient-specific model, which, in addition to the imaging reference and all the other tools that the surgical team have at their disposal, was used to help plan this surgery, practice this surgery, and ultimately result in a successful outcome. Very much on a different scale of things. So I'll now move us over from pre-surgical assessment and planning to anatomical training. So one of our clients at 3D LifePrints is the University of Oxford, and especially in the University of Oxford, it's their anatomy department. So their anatomy department has recently engaged on a very advanced task to update their teaching curriculum. So at the minute, a lot of the anatomical education in Oxford is done using cadaveric studies, cadavers themselves, anatomical models, textbooks, etc., etc. Now, we've noticed a problem, or the Oxford team noticed a problem, and they came to us and they said, as the majority of the teaching is cadaveric based, there are often areas of the anatomy which aren't well preserved in cadavers, specifically vasculature, nerves, soft tissue, etc. So we've embarked on a series of models with them, and I'll show you one of these models at the minute, which is the base of skull, to enhance the current curriculum and enhance the cadaveric teaching with lifelike models of the anatomy taken from live anatomy, not taken from cadavers, which show the actual anatomy of these structures, which degrade quickly in cadavers. So that was a summary of, well, I've just given us a little bit of a summary about this model. The focus for this particular model was the base of skull and the 5 bones of the skull, as are listed here. Also important was the cochlea, as we could pull that from the CT scan that this model originated as, and specifically the cranial nerves. So the cranial nerves and their travel through the base of skull was the main goal from this model. So the basis of this model began in Simpleware once again. And once again, we picked a high quality CT scan of the base of skull. This in particular, we picked a scan with especially thin slices. So we had 600 micron or 0.6 millimeter slices for this particular model. And this enabled us to produce this beautiful reconstruction of the base of skull and all the extremely fine detail of the foramen and the fossa where the vasculature and the nerves will travel through, of specific importance as well, and where a lot of time was spent in the 3D modeling reconstruction was around the nasal bones, the septums, the very, very thin bones here in the base of skull. And just so we can appreciate that, I'll give us a quick axial fly through of this particular model. I'll even zoom in a little bit more here. We can actually, in green here, I've left the cochlea visible, so we can see the little structures here that were used to define the cochlea. And then going back to those thin bones in the face, especially here around all of the sinuses, the septums, the orbital floors and the orbital cavities, a lot of manual work was done here to bring in those really fine structures, which needed to be very well defined in this detailed anatomical model. So I'll give us another quick fly through there of this beautiful base of skull model which we created, and I will switch us back to Simpleware and show you now what happened after Simpleware and what we did to enhance this process. So it was very important for our client that we based as much of these anatomy models as possible from live patient imaging, which is why we took all of the bony anatomy and the cochlea, which is visible here, from the patient scan. However, there's a lot of detail here, especially around the cranial nerves, which wouldn't have been easily derived from patient imaging and equally wouldn't have been well illustrated in cadavers. So we worked with a team of anatomists and freeform medical modelers to add in all of these beautiful structures, showing the path of the 12 cranial veins, showing the neurovasculature, showing the brainstem, showing the pituitary glands. And in essence, on the left here, you can see all the work that went into the digital design and the enhancing on top of the anatomy model, which we, as I mentioned, designed in Simpleware, or segmented in Simpleware rather. And then we used alternate 3D softwares such as Blender and Mesh Mixer, which is an Autodesk software, to add in these anatomical structures. And we went through rounds and rounds, tens of rounds of revisions so that the anatomists were happy. We would reference textbooks to ensure that all of the structures were designed in a way that was accurate. And then eventually we went to 3D print the model, which you can see here to show these beautiful cranial nerves. So the material selection of the model mainly was around flexibility. So we were able to 3D print and manufacture these nerve models in a flexible material, which enhance their longevity. So it means they'll be less brittle and less likely to snap, for example, and also mimicked the flexibility of nerves in real life. Interestingly, there have been several lines of evidence. Again, we always like to talk about the evidence for what we do, about the evidence that supports the use of 3D printed models in teaching, showing that medical students who have had the opportunity to learn using 3D models in addition to cadaveric models show positive results. And as we can see here, 3D models can act as valuable alternatives or can obviously be used in conjunction to existing cadaveric teaching and existing anatomical teaching. So that brings me to the end of my case studies and presentations today. I want to thank you all for your attention, and I will pass you back over to David.
Thank you very much, Mikey. It's really nice to see all of the different cases you presented today that 3D LifePrints have worked upon. And really inspiring to see how you've been able to positively affect people's lives. So thank you also to everyone who's listened today. If you're really motivated to come and try Simpleware software, we have a 30-day free trial that you can use. We can do personalized demonstrations if you'd like, and we also have a bank of recorded videos that you can watch, on-demand webinars and the like. If you go to our website, you can see those links on the screen, and you can also send us an email if you want to have a conversation about the different usage. But thank you very much, and now we'll open the Q&A session and answer some of your questions.
So thank you so much, David and Michael, for the presentation today. We'll now open up the Q&A. We've already had a few questions come in during the presentation, which is brilliant. Just to remind you, if you do have any additional questions, please type those into the Q&A toolbox that you should see in your GoToWebinar tool panel, and we will get through as many of those as we can. So first off, we have a question about the case 1 that Michael talked about earlier. The question is, for use case 1, given the vasculature inside the tumour, would an electronic model have been useful to have, either in addition to or instead of the 3D print?
So an electronic model, would that mean sort of a soft copy of the model to have in addition to the 3D printed model?
Yeah, I suppose it would be referring to having a model that you could interact with either on a computer or in front of you, kind of like the 3D view, I suppose, in Simpleware.
Absolutely. Well, for each and every one of these anatomical model cases, we supply a 3D PDF of the case. And what that is, for those of you who've not interacted with one before, in essence, it's a PDF document which has a live 3D model viewer embedded in it. And you actually have the specific 3D model structures, like was shown in the Simpleware 3D model preview, and you have the ability to hide certain structures. So you could, for example, hide the tumor, just make out, the descending aorta or the IVC structures which were encased in the tumor, some of the renal vessels as well. But absolutely, it's not a prerequisite to 3D print models in each and every case, and in some cases it may well be that the digital reconstruction is enough.
Okay, brilliant. Thank you for the answer. Next question is about, I guess, the scale of the models that you can print. So what's the smallest anatomy you can print out of your printing infrastructure?
That's a great question. And at the minute, 3D printing is so advanced, especially the multi-material polyjet printers that we used for both of these models, that the printers are often laying down between 16 and 32 micron layers of detail. So what we have always found to date is that, being that the scanning technology, you would only ever clinically get a CT that maybe has 500 micron slices. So in essence, my answer is we've so far never been limited by the printing technology, tend to be limited by the scanning technology in terms of the level of detail we can go down to. To give you an example, some of the nerve structures in the second use case, the cranial nerves, those were maybe 100 microns thin, and they 3D printed quite well.
Okay, perfect. Thank you. So we've got a few more questions have come through. This is again another question saying, hey, thank you for the great webinar. This is regarding the tumor case. If they've heard correctly, does Synopsys use an automated tool for the tumor segmentation? Perhaps you could go over the details you used for the segmentation steps again.
Sure. So when we ran this particular case, we used a semi-automatic tool called 3D Wrap to help us get the major mass of the tumor as much as was visually interpretable from the scans. I don't know if someone on the side of Synopsys wants to maybe explain the tool a bit better than I may be able to.
Yeah, I mean, David,
So,
do you want to take that?
well, certainly, yeah, I can speak on that a little bit. So the 3D wrap tool really works on the basis of segmenting individual images in two different planes, with obviously a large gap in between those segmented slices, and then utilizing the tool itself, you're able to wrap in 3D around that sort of, I'm trying to think of an example, the sort of skeletal structure that you've created for that segmentation, and then the bounds of that segmentation will be kept. I don't know, it's hard to explain with just words and not pictures, but I hope you get an idea. But certainly, you know, the tool is available to trial for yourself, so you can have a look at that function if you like. You're more than welcome to download the trial and have a go with it. Tim, I don't know if you want to add anything to the description of the 3D wrap tool, if there's anything pertinent that you think it would be good to know about it.
No, I think you've summed it up quite well. I think the key here is because it's quite a unique model, and it's quite hard to see the contrast between the tumour and the soft tissue around. There was some expertise on the engineering side at 3D LifePrints to identify that boundary, and then they used a little bit of that manual expertise with the 3D wrap tool to automatically then fill in the rest of the tumour. So it's a combination of the two, I suppose, in this case.
Yes, so I think the way to think about the tool is an optimized workflow for segmenting. So there's a bit of manual work that goes into it, and then you can use some automatic interpolation of that information to create the full segmentation. So it's very much a kind of an integrated segmentation tool. For completely automated tools, we have new offerings such as the AS Ortho product, which are kind of one-click options, but that's a very different tool in itself.
Great.
Okay, so I'll hand back over to you, Tim.
Thank you, David. Thank you, Michael. We have another question, kind of following on a little bit from that, asking if you had both CT and MR modality scan data, is there a way you could perform image registration and use both for complex cases?
I know we do this frequently in 3D LifePrints, and I'll let one of the Synopsys team talk a bit more about that functionality.
Yeah, so I can expand on that one as well. Essentially, yes, we have tools for both automatic or landmark-based registration processes, so that you can then have the registered data sets in the same location, and then you could use the CT for maybe the bones or the vasculature, and the MR for the tumor or the soft tissues. So yes, that's definitely something that can be done. We'll probably do maybe one more question, unless there's more coming through. This is a question about the setup in hospitals. And the question is, for Michael, how much does it cost to have 3D models built for a hospital? And they're talking about maybe 200 to 300 3D models per year. So I don't know, perhaps you can talk about that a little bit if possible.
Yeah, sure can. So in each of our contracts that we have with NHS trusts around the country, the contracts are completely unique to the needs of the exact center. You know, up in Liverpool, we produce hundreds of pediatric models in a variety of materials, ranging from cutting edge, you know, soft tissue mimicking materials. Over in Wrightington, we produce hundreds of drillable and operable bone models for the orthopedic center. So unfortunately, in this business we operate, there's not really a one-size-fits-all answer for your question. All I can say is we are an extremely flexible company who always looks to supply the exact needs of the centers we partner with. And I would be more than happy to give you a more specific ballpark idea if you get in touch with me after the webinar. We are always happy to provide, you know, some more tailored figures that would suit your exact needs once we know materials, quantities, amounts, etc.
Perfect. Thank you very much. I think we'll probably stop there. Thank you so much for all your questions. Just say thank you again to Michael and David, and offer them any chance to say any closing remarks.
Yes, so this is David. Just wanted to say thank you very much, Michael, for joining us today and providing such great material. It's really good to have your examples presented, and we're really proud of how you use the software. So thank you very much again.
Most welcome. Thanks to the Synopsys team and for everyone listening in today as well. Thanks for the great questions, and enjoy the rest of your week. Bye-bye.
Bye-bye. Thank you very
Bye-bye.
much, everyone.
Yeah, thank you very much, everyone.